The points within and on the boundary of the feasible region represents the feasible solution of the constraint. A function of the form z is equal to ax plus by, where a and b are constants which has to be maximized or minimized, is called as the linear objective function. The common region determined by all the constraints including the non-negative restrictions is called as the feasible region. Hello dear students, welcome to this session of Operation Research class, OR class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now, in this session I am going to discuss regarding the solution of a linear programming problem. So, there are different methods to solve the linear programming problem. So, in your syllabus, you are going to study there are four methods. There are four methods to solve a linear programming problem. So, the first method is the graphical method. First method is the graphical method to solve the linear programming problem. The second method is the simplex method. And the third one is the big M method. This is the third method. So, there are four methods. First one is the graphical method. Second one is the simplex method. Third one is the big M method. And the fourth one is two-phase method. That is called the two-phase method to solve a linear programming problem. The fourth method is called the two-phase. So, these are the four methods used to solve a linear programming problem. So, to solve a linear programming problem, there are four methods. We are going to study four methods to solve the linear programming problem. The first one is the graphical method to find the solution of a given linear programming problem. Simplex method, second, and the third one is big M method, and the fourth one is two-phase method. So, in the examination for 2 marks they may ask, write the different methods to solve the linear programming problem. For 2 mark question they may ask this question, write the different methods to solve a linear programming problem. The four different methods to solve the linear programming problem are graphical method, simplex method, big M method, and a two-phase method. Now, in this session I am going to discuss regarding the first method, that is the graphical method. How to solve a linear programming problem using graphical method. Now, let me discuss in detail what is the procedure to solve the linear programming problem graphically. Now, LPP can be solved by graphical method if and only if they have two decision variables. If they have two decision variables x and y, or x1 and y1, x1, x2, or x and y as the decision variable. If an equation have two decision variables, then we can solve graphically. So, a linear programming problem can be solved by graphical method only if they have two decision variables like x and z or x1 and x2. Now, how to solve the procedure? What is the procedure to solve the linear programming problem? So, first step is convert the inequality constraints. So, the inequalities of the constraints is converted into equal to, that is, the inequalities like less than or greater than is converted to the sign equal to. So, that is, convert the inequality constraints into equations by replacing less than or greater than into equals. So, that is the first step. So, let us convert the inequalities into equation by converting less than or greater than into equal to. Next, second step is equation can be represented in a form of a straight line on the centimeter graph sheet. So, the equation can be represented in the form of a straight line. So, usually the equation is of the form y is equal to mx plus c or x by a plus y by b is equal to 1, where this is nothing but the intercept form of a straight line where x-intercept is a and y-intercept is b. So, therefore, the equation can be represented in a graph sheet by a straight line. So, this is x-intercept a comma 0 and y-intercept 0 comma b. Okay, that is, equation can be represented in a straight line by the centimeter graph sheet representing x1 along x-axis and y1 or x2 along y-axis, or x along x-axis and y along y-axis. So if we represent this as x1 along x-axis and x2 along y-axis. Okay. Next, the third step is, for the straight line drawn on the graph divides the space into two parts, while all the coordinate values x1, x2 are x comma y. The coordinates x1 comma x2 are x comma y on the straight line would satisfy the equation. So, if the inequality constraints corresponding to the line is less than or equal to means then the feasible region lies towards the origin. If the inequality of the equation is less than or equal to, then the region below the line in the first quadrant will give the shaded. That means, if the inequality is less than or equal to, then the feasible region lies towards the origin. Next, suppose if the inequality constant is greater than or equal to 0, then the feasible region lies, that is, away from the above the origin. So that is, if for the inequality constraints, the region above the line in the first quadrant is shaded, that is, above the origin is the shaded region. The points lying in the common region will satisfy all the constraints simultaneously, then that common region thus obtained is called the feasible region. If the region which satisfies all the points lying in the common region is called as the feasible region. Now the very important, determine the feasible region. Then the feasible region forms the polygon where the sides are taken into the consideration with x1, x2 points or x comma y as the points. Each side values are applied to the objective function, and depending upon the constraints, we are going to get the maximum and minimum value of the function at x1 comma x2. So then the region is called the feasible region or the feasible space. Okay. Now let us come to few definitions. What are the important definitions we come across? Already we have studied this. I explained already in the previous classes. Let me explain once again. Definition. What is the definition of a linear programming problem? A linear programming problem is one that is concerned with finding the optimal value. So here in this session, we are going to find the optimal value by graphical method, that is maximum or minimum value of a linear functions of several variables. So a linear programming problem is nothing but finding the optimal value. Optimal value is nothing but the finding maximum or minimum value of the function of a linear function of several variables. Now what is linear objective function? A linear objective function, a function of the form z is equal to ax plus by, where a and b are constants which has to be maximized or minimized, is called as the linear objective function. Objective function, a linear objective function means a function z is equal to ax plus by which is to be maximized or minimized is called the linear objective functions, where a and b are called the constants. Now the feasible region. What is the feasible region? The common region determined by all the constraints including the non-negative restrictions. The common region determined by all the constraints including the non-negative constraints, and that is x is greater than 0 and y is greater than or equal to 0 of LPP is called the feasible region. That is the common region determined by all the constraints including the non-negative restrictions is called as the feasible region. Now feasible solution, this is very important. Point within and on the boundary of the feasible region. The points within and on the boundary of the feasible region represents the feasible solution of the constraint. So the points within and on the boundary of a feasible region will represent the feasible solution of the constraints. And the final, optimal solution. What is the optimal solution? So any point in the feasible region that gives the optimal value, that means the maximum or minimum value of the objective function, is called the optimal solution. Now, what are the steps we are going to follow to solve a linear programming problem is, first, just find out the common region, that is feasible region, then feasible solution, and that is the optimal solution. The optimal solution is nothing but any point in the feasible region that gives the optimal value, that is the maximum or minimum value of the objective function, is called the optimal solution for a given linear programming problem. Now, let us discuss how we are going to solve. Okay, let us come to the first problem. Let us take this problem. Solve the following linear programming problem using graphical method. What is the given problem? Maximize z is equal to 60x plus 15y subjected to constraints x plus y is less than or equal to 50, 3x plus y is less than or equal to 90, x is greater than or equal to 0 and y is greater than or equal to 0. Now, let us convert these inequalities into equalities. Now, what is given? The given objective function is max z, maximum of z is equal to 60x plus 15y. Now, what are the constraints? Convert these constraints into equalities. X plus y is less than or equal to 50 can be written as x plus y is equal to 50. Let us represent this as equation number 1, and the second equation 3x plus y is less than or equal to 90 can be written as 3x plus y is equal to 90. So, these are two lines. So, there are two linear equations, x plus y is equal to 50 and 3x plus y is equal to 90. Now, let us find out the points for these two lines. Now I will go to the next page. Let us consider the first equation for the line, for line 1, first line. What is the first line? X plus y is equal to 50. Now, put x is equal to 0, you will get 0 plus y is equal to 50, y is equal to 50, therefore the point A is equal to x is 0, y is 50. Okay, similarly, put y is equal to 0 in this equation, x plus 0 is equal to 50, x is equal to 50, therefore the other point B is equal to 50, 0. Right. Now, similarly, for the second line, what is the second line? The second line is 3x plus y is equal to 90. Put x is equal to 0. You will get y is equal to 90. Therefore, the point C is equal to 0, 90. Similarly, put y is equal to 0 in this equation. 3x plus 0 is equal to 90, or 3x is equal to 90. X is equal to 90 by 3 is nothing but 30. So, therefore, the other point D is equal to 30, 0. Like this, find out the points. Why we are putting x is equal to 0 and y is equal to 0 means, an equation of the form, any equation of the form x by a plus y by b is nothing but a straight line. This is an equation of a straight line which cuts the x-intercept at a and y-intercept at b. Therefore, the coordinates of a are a, 0 and the coordinates of b are 0, b. So, if you put x is equal to 0, you will get y coordinate. If you put x is equal to 0, you will get x coordinates. Therefore, this equation for getting the points a and b, we are going to put x is equal to 0 and y is equal to 0 for the given equation. So, now let us plot all these points on a graph sheet. Now, what are the points? A is 0, 50. Let me take the points. A is 0, 50. B is 50, 0. C, 90 and D 30, 0. Now, let us consider the scale. X-axis. On x-axis, 1 centimeter is equal to 1 unit, and similarly on y-axis, 1 centimeter is equal to 1 unit. Okay. Now, let us mark this as 10. This is 0, 10, 20, 30, 40, 50, 60, 70. Again, if I go, this is x-axis, 80 and 90. So 1 centimeter here, 1 centimeter is equal to 10 units. Instead of 1 unit, let us consider it as 10 units. 10 units. So this is again 10, 20, 30, 40, 50, 60. Now come to the first point. What is the first point? We have x0, y is 50. This is the first point. A 0, comma 50. Now come to the second point. B. What is B? 50, comma 0. X is 50. This is the point. B. X is 50, y is 0. Okay. Now let us draw a straight line. This is nothing but x and y intercept. Intercept form of a straight line. Draw a straight line. You can use the proper scale. This is. Now what is the condition here? We have here this line is nothing but x plus y is less than or equal to 50. X plus y is less than or equal to 50. That means here less than or equal to 50. X plus y is less than or equal to 50 means a straight line which the feasible region for this is towards the origin. That is towards the origin is the feasible region, because x plus y is less than or equal to 50. Less than 50 comes towards the origin 0, comma 0. Therefore the feasible region is towards the origin, that is towards downwards region. Now come to the second point. What is the second point? We have C. For the second line, C is 0, comma 90. C 0, comma 90. X is 0, y is equal to 90. Let me consider this as 90. 0, comma 90. Y is 90. And again D 30, comma 0. 30, comma 0. This is D. 30, comma 0. Now draw a straight line. So I will draw a line like this. What is this? Here the line is 3x plus y is less than or equal to 90. This is again 3x plus y. So this is 3x plus y less than or equal to 90. That means the feasible region is again downwards for this. So therefore the feasible region, this is the feasible region. So the feasible region is, I can write this as the, now this is the feasible region. Now find out the corner points. What are the corner points? So this is the point E. What is this? So exactly this will cut the axis. So if we solve, on solving the equation, solving x plus y is equal to 50 and 3x plus y is equal to 90. If you solve this, subtract, you will get minus 2x is equal to minus 40, x is equal to 20. So you will get x is equal to 20, and from this y is equal to 50 minus 20 is 30. Y is equal to 30. This is the point. So therefore the corner points are O 0, comma 0 and this A. So therefore the corner points are, therefore the corner points O 0, comma 0, A. What is A? A is equal to 0, comma 50 and then E. E is equal to 20, comma 30 and then the last point where it cuts at D. D is equal to 30, comma 0. So these are the corner points. Now substitute these points in the given value, max or minimum, you will get the required solution. I will come to the previous page. I will substitute here. I will substitute in this equation. Now at first point O 0, comma 0, max z is equal to 0. At the second point, what is the second point? At A 0, comma 50, A 0, comma 50 and again what is another point? E 20, comma 30 and another point D. What is the other point? D 0, comma 30. Let us check what you will get. Max z is equal to x is 16 to 0, 0 plus 15 into 50. So 15 into 5, that is equal to 750. Next, at this z is equal to 60 into 2, 60 into 20 plus 15 into 30. That is equal to 1200 plus 450. This is equal to 1650. Now at the corner points A, maximum of the Z value is 0. At A, at O it is 0. At A 0, 50 it is 750. Then at E 20, 30 Z is equal to 1650. At D is 30, 0. Z is equal to 60 into 30 plus 15 into 0. This is nothing but 1800. Now what is the maximum value here? The maximum value is, this is the maximum value. So this is maximum. So therefore the function is maximum at 1000, maximum is 1800 at 30, 0. So therefore maximum value is 1800 at the point 30, 0. This is the required solution. This is the method to solve a LPP using graphical method. Now let us come to the next problem. Solve the following linear programming problem graphically. Minimize Z. I will take minimize Z is equal to 3x plus 5y subjected to the constraints. X plus 3y is greater than or equal to 3. X plus y is greater than or equal to 2. And xy is greater than or equal to 0. This is the second problem actually. Second problem number 2. Now what is to minimize? Here it is to minimize. Minimize of Z is equal to, the objective function is minimum Z is equal to 3x plus 5y subjected to constraints the given. Now writing the given inequalities into equalities, the given equations can be written as x plus 3y is equal to 3. This is equation number 1. And another equation, x plus y is equal to 2, equation number 2. Now solving these two equations, find the points, put x is equal to 0, you will get 0 plus 3y is equal to 3, 3y is equal to 3, y is equal to 3 by 3 is equal to 1. So therefore a is equal to 0, 1. Again put y is equal to 0, you will get x plus 0 is equal to 3, x is equal to 3, therefore the point B is equal to 3, 0. Similarly, come to this, put x is equal to 0, you will get y is equal to 2, therefore C is equal to 0, 2. And put y is equal to 0, you will get x is equal to 2, therefore D is equal to 2, 0. Okay. Now, solving these two equations, if we solve x plus 3y is equal to 3 and x plus y is equal to 2, subtract this, you will get minus and minus x plus x gets cancelled. 2y is equal to 3 minus 2 is 1, y is equal to 1 by 2. Now from this equation x is equal to 2 minus y, this is 2 minus 1 by 2, 2 to the 4 minus 1 is 3 by 2. So therefore x comma y is equal to, x is 3 by 2 and y is 1 by 2. Now these are the points. Now let us represent this in a graph sheet. So what are the points we are getting? Therefore a is equal to 0, 3, 0, 1. B is equal to, what is B? 3, 0. And what is C? C is equal to 0, 2. And D is equal to 2, 0. Now let us represent this on a graph sheet. I will represent it on a graph. Let us consider the scale. X-axis, 1 unit is equal to 1 centimeter, and on y-axis also 1 unit is equal to 1 centimeter. Okay. Now let us consider this as the x-axis. This is x-axis and y-axis. Now this is the origin. Each unit is equal to 1 centimeter is equal to 1 unit. 1, 2, 3, 4. Here it is 1, 2, 3 and 4. Now what is the points we are getting? X, A 0, 1. When x is 0, y is 1. This is the point A 0, 1. Next What is B? B, 3 comma 0. X is 3, 1, 2, 3 and Y is 0. This is B, 3 comma 0. Draw a line, just this is a straight line. Okay. Now what is the curve we are getting? X plus 3Y is greater than or equal to 3. That means the feasible region is away from this. This is, the equation is X plus 3Y is greater than or equal to 3. The feasible region is away from the origin. Now come to the next point. What is the next point? What is C? C is 0 comma 2 and D is also 2 comma 0. C is 0 comma 2, X is 0, Y is 2. This is C. And what is D? 2 comma 0. This is 2 comma 0. Now draw the line, straight line. Now what is the equation given? X plus Y is greater than or equal to 2. This is X plus Y again. X plus Y greater than or equal to 2. Greater than or equal to 2. That means here X plus Y is greater than or equal to 2 away from the origin. So you are going to get this as the feasible region, unbounded region. This is the feasible region. So this is the feasible region for this. Now what are the corner points? So O, the corner points are O, 0 comma 0, O, and then it is this point A, that is C, 0 comma 2, and let us represent this as the point E. What is E? E is equal to how much you are getting? 3 by 2 comma 1 by 2. This is 3 by 2 comma 1 by 2. And the last point is D. D, what is D? 2 comma 0. These are the corner points. Now find out the feasible solution. That's it. Now find out the feasible solution. So I will substitute here. So therefore at 0 comma 0, again B. What is B? B is 3 comma 0. B, then C 0 comma 2 and E. What is E? E 3 by 2, 1 by 2. So Z is equal to Z. What is Z given? Z is equal to minimum 3x plus 5y. This is the objective function. Z is equal to, at 0, Z is equal to 0. At this point, Z is equal to 3 into 3 plus 0, this is equal to 9. At C, Z is equal to 0 plus 5 into 2, it is 10. At this, Z is equal to 3 into 3 by 2 plus 5 into 1 by 2. You can take 2 is the LCM. 3 3 is 9 plus 5. This is 14 by 2 is equal to 7. What is required to find is the minimum. Minimum value here is, what is the minimum value? 7 is the minimum value. So therefore, the function is minimum. The minimum of Z is equal to 7 at, what are the points? 3 by 2 comma 1 by 2. The minimum value is 7 at 3 by 2 comma 1 by 2. This is how we are going to solve a linear programming problem using graphical method. See, very simple. The concept is very simple. Just convert the given linear inequalities into equalities. Less than or equal to or greater than or equal to can be written as equal to. First, solve the given equations. If 2 equations are given, solve the 2 equations. If 3 equations are given, solve the 3 equations. Put x is equal to 0, you will get y. Again put y is equal to 0, you will get x is equal to value. Then the points you are going to get as A and B for the first line. Similarly, solve the second equation, you will get the points as C and D. Flag those points in a graph sheet and find the feasible region. If it is greater than or equal to 0 means, then the feasible region is away from the origin. Less than or equal to 0 means towards the origin, and find out the corner point. Substitute in the given equation. find whether it is maximum or minimum. What is required to find? If it is maximum, find the maximum value at the corner point, find the minimum value at the corner point. That's how we are going to solve this linear programming problem graphically. That's all for today's session. Let us discuss few more problems in the next session. Thank you.